Kia ora. What are carbon environments and how do we identify them? So it's important to know that in a molecule you can get rotation about single bonds, and you do not get rotation about double bonds. So if I look over here now to work out which carbon atoms are in the same environment, they have similar um, neighbors close by and others further away. And bearing in mind, if they can rotate, then what may look in a different environment is actually the same. And one of the easiest ways is to ask yourself then two questions. Can all the bonds rotate freely? So in other words, are they single bonds? Because double bonds can't. And so they're slightly different, and we'll have an example of that later. And what groups are bonded to each atom? So if I take this first molecule here of ethane, this carbon is bonded to 3 hydrogens and a methyl group. The second carbon is bonded to 3 hydrogens and a methyl group. And because all those bonds can rotate freely, we'll consider them to be in the same environment. So this carbon is identical environment to the second carbon. If I look at this second molecule, propane, then we can count what is bonded to each of these carbons. So that this end carbon has 3 methyls and 3 hydrogens and an ethyl. And this end carbon on the right-hand side is 3 hydrogens and an ethyl. But the middle one is different because it's got 2 methyls and 2 hydrogens. So it has what we call 2 carbon environments. The 2 end ones are identical, but the one in the middle is a bit different because it's got different groups on it. If you look at butane, then you'll see there are 2 carbon environments as well. The end ones, because they've got 3 hydrogens and a propyl group, and the 2 middle ones are different to the end ones, but the middle ones are the same because they're attached to 2 hydrogens, a methyl, and an ethyl each. So if you think of this carbon, here's the methyl, there's the ethyl, and the 2 hydrogens. So there are only 2 carbon environments. If I go to pentane, how many environments do you think? Hopefully you came up with 3, the 2 end ones, 3 hydrogens and a butyl. The one in from each end is 2 hydrogens, a methyl, and a propyl, and the one in the middle is 2 hydrogens and 2 ethyls. So there are 3 carbon environments. The green carbon has got different neighbors to the red carbon, but the 2 red carbons have got the same neighbors as the identical neighbors, and then the 2 end ones also have identical neighbors to each other. So here's some practice. Work out which ones these are, and then here are the answers now. So if you look over here, I now have an OH. So just be careful of the functional groups. They aren't all hydrogens. There may be a functional group, and that will change it. So this carbon has got an OH, 2 hydrogens, and a methyl, whereas this one has got 3 hydrogens and a hydroxymethyl. So they are not the same. So there are 2 different carbon environments. This one, the OH is in the middle. So the middle carbon has got a hydrogen, an OH, and 2 methyls. And each of the terminal ones has got 3 hydrogens and a hydroxyethyl. This one has 3 hydrogens and a hydroxyethyl. So the 2 terminal carbons are identical. The one in the middle is different. There are 2 carbon environments. Can you work out what this one is? Hopefully you'll see that each of these are bonded to different groups. So when I say a group, I mean an atom or an OH or something like that. So they are bonded to different things, and therefore there are 3 different carbon environments. Over here, it's the same thing. Every one will be different because if you count what is all bonded to the first carbon or the second one or the third one or the fourth one, they will all have different groups attached to them. If I have this one over here, you'll notice they are also all the same. Compare this to butane, where we only have 2 carbon environments, but here again there's not a single carbon atom that has exactly the same identical groups as another one in this molecule. In 3 or pentan 3-ol though, I do have carbons that are in identical environments. So I only have 3 carbon environments because the 2 end ones are attached to 3 hydrogens and a 2-hydroxybutyl, the same as this one. So these are identical, this one is identical, and then this one is different. Often looking for symmetry will help you quickly spot the number of carbon environments, but it depends on how that molecule is drawn. It may be more difficult to spot symmetry in one molecule than the other. So counting all the groups on each carbon is the best way. Over here, you can hopefully see that there are 3 carbon environments because this methyl is actually identical to that methyl. So it doesn't quite look it if I just drew it like this. But if you checked the groups attached, you will find that these are identical. If we look over here, though, they are 5 carbon environments because that methyl is not the same as this methyl, because the fourth group is actually different. It might have 3 hydrogens, but this is a different group. It's a 1-hydroxybutyl, whereas this one is a 2-methyl 1-hydroxy propyl. So it's a different group. So that methyl is not the same as this one. And finally, we have here something where we don't have all single bonds, so the bonds do not freely rotate about the double bond. And because of that, this methyl is not the same position as that one because it is closer to the hydroxy group, and this carbon is further from the hydroxy group than that one. So when you have a double bond, just counting the number of groups doesn't quite work. You've got to also see, hey, is it closer to something than the other? So these are the 4 different carbon environments. So hopefully you can spot the number of carbon environments. Just remember, be systematic and count all the groups, and then just be aware if you've got a double bond, look simply to see what neighbor is closer than the other. Kia ora.